Hello class, welcome to Solving Equations Part 2. Today we're going to be solving two-step equations. When solving an equation, you need to isolate a variable. Just like before. To isolate a variable, you need to do the opposite operation. And when you have multiple operations present, it is important that you do things in a specific order. First, you move the adding or subtracting. Then you move the multiplication or division. Let's do a few examples, and then the rest of the time will be yours. First, here, we have 3x minus 4 equals 12. So the first thing we need to do is move the adding or subtracting over before we do dividing. So the opposite of subtracting 4 would be to add 4. So now I have 3x equals 12 plus 4, which is 18. Then, to isolate the x, since 3 or x are being multiplied, I divide by 3. So x equals 18 divided by 3, which is 6. This next problem seems a bit tricky because it has a fraction, but don't let the fraction fool you. The process is still the same. We have multiple operations happening. We have a division here, and we have an addition here. First, we will move the addition by doing the opposite operation. We will subtract. So we still have the x over 2, the 8's canceled, and we have 12 minus 8, which is 4. Then, since it's x divided by 2, the opposite of dividing by 2 is multiplying by 2. The 2's cancel, and you are left with 4 times 2, which is 8. For example 3 here, it looks a little different than the previous problems, but the process is the same. First you subtract 7. This time we're subtracting to the left. And we have 12 minus 7, which is 5. Then we have 6 times x equals 5. We will divide both sides by 6. Now don't get upset. This is going to be a decimal approximation, or you can just leave the answer as 5 over 6. That's perfectly acceptable. But if you wish, you can punch 5 divided by 6 into your calculator and round to 2 decimal places, or to the nearest hundredth, which would be 0.83. And let's do our last example, example 4. Oh, we have another example. So again, we have a fraction. Don't let that fraction frighten you. And we have adding. So we want to try to work on getting the x by itself. So this term is going to stay, and everything else is going to move. So this 5 moves over to the 10. So I have 2 over 3 equals 15. And if you recall from our last video, I usually like to break this fraction 2 over 3 into 2 separate steps. First, I will multiply to get rid of the fraction. 3's cancel, and I'm left with 2x. And then I have to do 15 times 3, which is 45. Then I can isolate the x further. Since it's 2 times x, I will divide by 2. And again, 45 over 2 is not a nice, pretty whole number. It's 22.5. and it's okay that your answer is a decimal. Let's examine a word problem. If you get paid a flat rate of $100 and an hourly rate of $5 per hour to paint a room, how long will it take you to earn $155? So you want to earn $155, and your pay is comprised of these two pieces. You get paid a flat rate of $100. That means just to walk in the door, you get $100. No actual work required. The rest of your pay is determined by the number of hours you work. You get $5 for every hour that you work. So H is your variable, and 100 needs to move over to the other side. We're trying to isolate H right here. So I have 55 equals 5H. Then I divide by 5. Because it's 5 times H equals 55. So H, the number of hours that I have to work, is 11. This concludes our video. Feel free to rewind it or rewatch it, or you may start on your assignment.